Section 7.2, similar polygons. We're going to identify and apply similar polygons. So first we need to know what they are. Similar figures have the same shape, but not necessarily the same size. The symbol for it is a little tilde. If you've taken Spanish, it's just that little curly hyphen, so to speak, thing. So similar, same shape. One might be bigger, the other might be super small. Some might be similar in size, but just not exactly the same size. Two polygons are similar if corresponding angles are congruent and if the lengths of the corresponding sides are proportional. So you can't just look at the shape and go, yes, I think that's a similar figure. You have to look at the angles. All the angles are going to be the same. All the sides are going to be the same proportional length. So if there's a small one and a large one and every single side in the large one is 2 times bigger, then they're similar. If you have 3 of the sides being 2 times bigger and one being 1.5 times bigger, then they're not similar because every single side has to be that same ratio. So we're going to find out, how do we find the ratio? How do we find those missing sides and angles and things like that? So if you look at this shape, it's a quadrilateral. They have the angles marked. A and G are the same, B and H are the same, C and I are the same, D and J are the same. So you'd write all those down, and then you look to see, are all the sides proportional, or do they all form the same fraction or whole number? Extended proportions are when you have more than just 2 fractions being the same. The scale factor is that number. So if you can figure out how many times bigger or smaller something is, that's the scale factor. Usually they go first one to second one, not necessarily always 2 times bigger or 3 times bigger. It could be half as big or something like that as well. We are going to look at things like this. Notice how they have A and X the same, B and Y are the same, C and Z are the same. So first, I always check the angles if I can, and then you look for the lengths of the sides. So when we do that, you are looking at, notice they're all sitting in the same way as well. The angles that are the same match. That's what you want to have happen. So 15 over 6, 20 over 8, 25 over 10 all need to go to the same ratio. So with this one, I'm going to write them all out. They, I think, just simplified one of them. So they did BC to YZ 20 over 8. I like to do them all at the same time. 15 over 6 and 25 over 10. And then what you can do is just grab your calculator, type them in as a fraction, hit your equals, and it will simplify it for you if you don't want to simplify them in your head. So if I divide by 5 on the last one, I get 5 over 2. If I divide by 3 on the second one, I get 5 over 2. And if I divide by 4 on the first one, I get 5 over 2. If these are all the same, that means that's what the scale factor is. So the scale factor, I always abbreviate SF, is 5 over 2. You could put 2.5, but most of the time for scale factors, they want you to put them in fractional form. Again, when we talked about this on Friday, there was 3 different ways to write a ratio. You could use the fraction bar, you could use the colon, or you could use the word TO too. Same thing, I always like to use the fraction one. Notice also they went from the left one to the right one. So the number that you got out of the left triangle needs to go on the top. The number that you got out of the right triangle needs to go on the bottom. If you do it that way every time, you will get them right. Or actually what they say, this one needs to go on the top. This one needs to go on the bottom. Okay, so sometimes they don't always go left, right. They go top, bottom, or whatever. Make sure you pay attention to the order that they want them in. Okay, so here's our first question. What are the pairs of congruent angles? Now notice here they say that these are similar. Do you have to look at the picture to know which ones go together? No, remember when we did congruent figures a while ago, and the first letter goes with the first letter, the second one goes with the second one? Same exact thing. So the congruent angles are going to be angle M congruent to angle S. So first letters go together, then we go angle N congruent to angle R, and angle P congruent to angle T. Notice the left one was written first, so that's the one that I grabbed my angle out of first. Then it says, what's the extended proportion for the ratios? Now, if you wanted to, you could draw your own pictures and then mark them that way. So M matched up with S, N matched up with R, and then P matched up with T. If that is easier for you to look at and figure out what they are, do it. This one isn't just flipped over or the same. They rotated it, and it's harder to tell that way. So I only go with the letters. I usually do not even look at the picture if the statement is already there. So what we're going to do is we're going to take these two at a time, and we're going to just compare them. So I'm going to erase this now. MN. So I'm choosing from the left one first. What two letters does that match up with when you're looking at that? SR. And you're just going to write it as a fraction. Most people want to put equals, but they're not equal because one is definitely smaller than the other. So you have to say, when it says ratios, that just means fractions. So now if I go NP, what does that one go with? RT. And could I switch the letters? No, the letters have to be in the right order. And this is a triangle, so you have three sides. So then I'm going to go MP, and that will match up with SR on the last one, or ST, sorry. So that's your extended ratio. So think about what the words mean. Ratio means fraction. Choose from the left figure first and match it up with two of those from the right. Could you switch the letters as long as you switch both of them? Yeah, so what if I said on the first one NM? That's okay as long as you put RS. So the placement of the letters in these is very important. So I'm going to say letter order matters on these. Now also, when you're looking at the angles, if you have triangles that do not even touch each other, you can always use a single letter for the angle. Okay, if you had triangles that were touching each other that shared a side, for instance, then you'd have to use three letters. But for these, when they're doing similar figures, usually they do not touch each other because none of the sides are really going to be the same. But just make sure you kind of are aware of that. If they touch in any way and you're wondering, now, is that M on the little one or M on the big one? What is it? Then you have to make sure you go with three. Otherwise, not important to do three. Okay, so on this one, notice there was no picture at all. We are going to do angles. Separate them. What goes with D? H. And you're just going to go right down the line. Angle E is the same as the second one in the second figure. So I'm going to go with J. Angle F is congruent to angle K. And angle G congruent to angle L. So the angles are really about the easiest thing you can do because they just go right in order. The sides, remember, if there's four sides, you have four sets of fractions and you're going to have them set equal to each other. So pick two at a time. So I'm going to go DE, then I'm going to go EF, then I'm going to go FG, and DG. So DG is the one that most people tend to forget when you use the first letter and the last letter together. Then you match them up with those same letters in the second figure. So I chose the first two letters, so I'm going to go with HJ. Then I'm going to go with JK. Then I'm going to go with KL. And then I'm going to go first and last letter. Okay, exactly the same thing. So you're just taking them two at a time and just moving to the right by one letter. Okay, now we have to check, are the polygons similar? So what you have to do is you have to first check angles. To check scale factor. So you have to do those two things every time you're looking for similar figures. And they're asking you this time, they're not telling you. So when you look at these figures, M and W are marked, J and T are marked, K and U are marked, L and V are marked. Okay, so the first thing you're going to do is write down all of those pairs. So it's kind of like you're doing a short little proof, but you don't really have to explain yourself this time. So angle M congruent to angle W, and we're going to go all the way around. J and T are the same, K and U are the same, and L and V. Okay, so we have our congruent angles. Now we have to check that ratio that we were talking about before. So I'm just going to go all the way around, kind of 2 at a time. If you want to write those letters down so that you get the right sides, you can. But when they're actually set like this, 6 over 6, 12 over 6, 24 over 16, and 24 over 14. So I'm just matching them up as I go around. So 6 over 6, 12 over 6, I can already tell that these are not the same, 24 over 16, and 24 over 14. Now, if we simplified those, would they be the same? No, because the first one gives you a 1, the second one gives you a 2, and then 24 over 16 and 24 over 14 are not the same either. So when you reduce them, you get 3 over 2. And 12 over 7. So these are not similar. Scale factors are not equal. Okay, so if you find even one that's different, double check it. But if it's not the same, then it's a no. This time they all were different, but on some of them, there's only one that might be different. Okay, you can go like this as well, you know, when they're not equal, but make sure that you give a reason. Here, all the angles were congruent, but sometimes that doesn't matter. Okay, so let's try another one. You guys go ahead and take out a piece of paper for your assignment, and let's try this one together. So first, check angles. So step 1, angles. What if you find angle pairs that are not the same? Do you have to do the rest? No. If you had, for instance, A didn't have a match in the second one, you could say not all pairs of angles are congruent. These are not similar. Okay, so sometimes you'll find it in the angles, but most of the time you'll find it in those corresponding sides. So I'll give you a Okay, so here's what you need when you're done. So if you are finished already, did you write down all the congruent angle pairs? If you didn't, you have to write those. That's part of it. A and D are the same, C and F are the same, B and E are the same. You're just looking at hash marks there. Then if you wanted to, you're kind of looking at similar figures right now, but maybe they're not. So I don't usually write down those letters yet. What I look for is when you write down the 8, you are looking for that side that goes between the single and double angle hash marks. So I go over here and go, okay, I'm looking at this one. So I wrote down 8 over 10. So the shapes are probably not going to be in the right order to just go from one to the other. You have to kind of look for them. So then the second one that I wrote down was the 12. So I'm looking at what side goes, the side that I'm looking for goes between the double and triple angle hash marks. So I look for those double and triples, and I wrote 12 over 15. That's how I do it. It's the easiest way that you can. One other thing that you could do, which is also pretty easy, when I look at the 12, it is opposite the angle. So we've already done that, so that might be easier yet. C goes with 12, and then the one that we're looking at needs to go opposite the single angle, which that might work as well. So 12 over 15. And then when you look for the last one, 16 is opposite the A, which is double, and the 20 is opposite the A, which is double. That's probably easier because you don't have to look for so many things. Then you type these in your calculator, 8 over 10, 12 over 15, 16 over 20. You get 4/5 for all of them, and my scale factor is 4 over 5. Now, however you write your scale factor, the numbers that you choose for the top are from the triangle on the left. The numbers that you use for the bottom number are from the triangle on the right. If you did this differently and you did the right figure first, you would have to show that in your statement that you do. So all of the angles then would be flipped over. All of the fractions would be flipped over, and then the ACB would be written second. So whatever you choose first goes on the top, whatever you choose second goes on the bottom, and you have to keep it consistent throughout. Okay, so let's do this one. We'll kind of just do this one together. So I'm going to look at the angles first of all. I'm going to go A, and so this one looks like they just flip it to the right. So I'm going to go A and S. B and R. C and V. D and U. E and T. So it looks like angles are all okay. Even though you can look at them and go, yep, they're all okay, you have to write them down. So this is part of it. So all looking good so far. Now we start writing down those fractions. So with this one, it's harder to go opposite because it's not a shape that there is really an opposite thing. So I'm just going to keep going around. So I'm going to go AE is 12. What does that match up with? The ST, which is 6. The 18 on the top matches with the top one on the other, so 18 to 9. Then we can go 18 to 9 again. That's the flat side on the right. 18 to 9 again. And then 12 to 6. Are those all the same? Yeah, they all, if you divide them, you get 2 or 2 to 1. So my scale factor is 2 over 1. Or you can just say 2, it works. And then they want a congruent set of, I think they just want the scale factor. So I think we're good the way we have them. Oh, let's go like this. A, B, C, D, E. Similar to, I went in order down these angles. A, B, C, D, E, so I can go S, R, V, U, T, and I don't even have to look at the picture anymore. So I'm going to do that. S, R, V, U, T. If the angles are the same and the scale factor is the same, then you do have similar figures. Sometimes they have overlapping figures like this one. They're just looking for one thing. So it tells us that these things are similar already. So we don't have to go through that big long process that we just did. So this is a key thing, and they'll do that whenever they just want you to find one thing. So it makes it a lot easier. So we are looking at setting up some sort of proportion so we can solve for those missing things. So 6 will match up with which part? So I'm looking at small to big. Actually, no, I can't do that. Notice how A, B, C, D is the big one. We need to do the big one on the top. So the big one is 9. What does that match with? If I'm looking at this one? 6. And then I'm going to go 5 matches up with which part? Yep. Could I solve for Y right there? Yep, I'm going to do that. So I'm going to just look at this one. 9y equals 30. They want the value x, but I know the question underneath wants y as well. So y is going to be the same as 30 over 9 or 10 over 3. So we actually answered your got it question already. Let's go back and find out the x value. 2. Let's go 7.5 over x. What do I match that with? You could do 10 over 3, couldn't you, for the y part? But let's use the same number that we used the first time. So if it's 9 over 6, we can use that again. So basically when you're looking at these, you're going to have a set that looks like a fraction and you're going to have both numbers. Use that thing twice. So this one's going to be 6 times 7.5 divided by 9. Put that in your calculators once. Because what's going to happen is you're going to get a decimal for that, I think. It probably won't let you put that in as a fraction. Okay, so let's do 7.5 times 6 and divide by 9. Oh, it isn't. It is 5. What if you got something like 5.3? You guys know how to change that into a fraction, right? If they're looking for a scale factor and you have a decimal, you always want to use that F to D key to change it into a fraction. So hunt around for your F to D key. I think it's just diagonal from your second function key. So let's do this. Let's type in a 5.3. Just type that in your calculator. Do second PRB, and it's just diagonal from that key, and you'll see above it F to D. If you hit that F to D, it will either turn a decimal into a fraction or a fraction into a decimal, whatever you want it to do. And it says 5 3/10. Now, I like to do improper fractions for scale factors because then the number associates with the picture that it is. So now let's hit second in your fraction key, and it'll change to the other form of the fraction that maybe you didn't get on your screen. So I'm looking at 53 over 10. So first turn it into a fraction, and if it's a scale factor, then turn it into an improper fraction, because then you can kind of see, oh, 53 over 10, that left picture must be the bigger one, the right picture must be the smaller one, and so on. So sometimes you get decimals, sometimes you don't. For sides, it's okay, but leave the scale factors as numbers. Let's look at the scale drawing part. Okay, so here in the scale drawing, all lengths are proportional to their corresponding actual length. So for a scale drawing, like if you have a building, the building is 3D. The scale drawing takes the building measurements and puts it on paper and makes it quite a bit smaller, so you can just look at it in a 2D setting. The scale is the ratio that compares each length in the scale drawing to the actual. So that's kind of like our scale factor that we've already talked about. The units of the scale can be different lengths. So they can say, and it's kind of like if you think about those directions on a map or the distances on a map, there's usually a scale at the bottom that says 1 centimeter is equal to 20 miles or something like that. You know, they'll associate it with something like that. So 1 centimeter is on the top, and it might be associated with a totally different unit on the bottom. So that's kind of what they're talking about there. Problem number 5. The diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. What is the actual length of the main span of the bridge? So when you're looking at it, they're looking at what is this distance right here. Okay, now it says the scale is 1 centimeter for 200 meters. Now we're not really into meters, but if you had to do that, what you're looking for is the actual length of that drawing. Now also when you look in your books, we're going to skip the dimensional thing for problem number 4 this time. Kids always have trouble with that one, and I'm just going to skip that one this year. So what we're looking at is we need to actually measure how many centimeters this thing is. So if you have your protractors right now, you can measure it. This one's in centimeters, so you do have to measure in centimeters. So I'm going to grab a ruler. I don't know if you guys have anything, but I'll do this one myself. Make sure you're on the centimeter side. It looks like mine is 7.3, but I know that they measured and they got 6.4. I'm going to actually see if that was written in the book. Just a second. They told us what it was. Now, when I'm looking at that one, I don't see that it's 7.4. I'm looking at, or 6.4. I'm looking more like 7.4, so I think they have a typo in there. Let's just go with 7.4. So when I measured, I got 7.4 centimeters. We want to know how many meters that is. So the small lengths are on the top, the big lengths are on the bottom. So how do we do this? As long as those units match, we're just going to cross multiply them. 200 times 7.4 is 1,480 meters. Now, the trouble with this one is if you guys measure and you get something a little bit different, like what happens if you measured and you got 7.3? Would that be a super big deal? Not really. You're setting it up right, but you just maybe measured wrong. Now, the book had 6.4. It's really, I think, 7.4. So as long as you set up your proportion, I'm going to actually see what you're doing. So any of the questions like this, you're going to get part of it from this little scale there, and that will tell you where those units go. So super easy to find the spot that they go to. And that is it.